particle moving in xy plane, with a constant acceleration. Okay, see, no more it is along x-axis, straight line, rectilinear, nothing. XY plane, he told in an XY plane with a constant acceleration of 1.5 meter per second square, So acceleration is how much? 1.5, and it is a constant. Very good. What's the meaning of this constant? I can apply my three formulas. What's that? V equal to V plus AT, S equal to V plus half AT square, and V square minus U square equal to 2AS. In the direction making an angle 37 degrees with the x-axis. Sir, I have reserved the angle beta for acceleration, and that beta is with x-axis only, right? It is 37 degrees. It is 37 degrees. Very good. At time t equal to 0 seconds, the particle is at the origin. Listen. At time t equal to 0 seconds, the particle is at the origin. Very good. Next, and its velocity v is, this is the starting velocity. As it is the starting velocity, what should I say? It is nothing but initial velocity. U is equal to 8 meter per second along the x-axis. So if it is along the x-axis, what will happen to the velocity of that angle? It is along the axis, so alpha will become equal to 0. Find the velocity and position of the particle at time t equal to 4 seconds. Find the velocity and position of the particle at time t equal to 4 seconds. See, this is the initially, and he is asking at this point finally. Please listen. So this is my Bengal, where I have to collect the taxes. Here what to do? Separate into West and East Bengal. Separate it into X and Y direction. Solve the problem separately. Take it to London. That is till t equal to 4 seconds. Solve it separately in X and Y direction. Mix in London. That is, combine them and get your final velocity and displacement. Are you okay? All of you. Now let us first split this. Now, this is my x direction, this is my y direction. Okay, please all of you listen, sir, listen. Initially I have taken small problems for the reason you'll understand it properly, then we can apply it in the complex problems. So be with me when I am doing these problems. My only target here is to make the concept digest for you. Please, it's a slow process, we'll go slowly. What is there? First, let us start with displacement. What he told for the displacement? Initially it is at the origin. So that means initially the point is at origin. The object is here. So what's the coordinates of this? 0, 0. So initially the position x is 0, y is also 0. Initially, this is the condition. Next, velocity. Initial velocity u equal to 8 meter per second, making an angle alpha equal to 0 degrees. Now, see, initial velocity is in this direction, u equal to 8 meter per second, making an angle 0 degrees because it is along the x-axis. Now, what will be the velocity in x direction? Sir, all the velocities in x direction are, if suppose it is making an alpha, if suppose it is making an angle some alpha, if this is alpha, then what will be this component? Adjacent side is cos, yes, and this opposite side is sine. So ux is nothing but u cos alpha. If suppose it is given some angle. Now cos alpha, what is alpha? 0 degrees. Cos 0, 1. That is nothing but u 8 meter per second initially. Now in y direction, it is nothing but how much? uy is equal to u sine alpha. Alpha is 0 degrees, so ui is 0. Initially velocity in x direction is 8, initially velocity in y direction is 0. Initially both are at 0 0. Next result we have acceleration is 1 point, constant acceleration. Remember this very carefully. 1.5 meter per second square, making an angle of 37 degrees. Acceleration A equal to how much? 1.5 meter per second square, making an angle of beta equal to how much? 37 degrees. All of you see here, acceleration x direction ax is nothing but what? Adjacent side, so it is cos component, a cos beta. What is a? 1.5 cos beta, cos 37 degrees. What is cos 37, sir? 4 by 5, so 5 ones are. So I hope everyone knows this. If you don't know, remember this triangle. If suppose this is 37 degrees, this will be right angle triangle, this will be 53 degrees. If this is 3, this will be 4, and this will be, smaller one for the opposite side, that is small angle opposite side. This is 3 and this is 4 and this is 5. And what is that? Even many are there, like 7, 12, 7 and 13, I think. So 3, 4, 5. Just at least remember this. This is very important one. 3, 4, 5. Now cos 37. Adjacent side 4 by 5. 4 by 5. So 5 ones are 5, 0.3s are. So 1.2 meter per second square. Similarly, AY is equal to A sine alpha. Sorry. Beta, right? For what is this? Acceleration it is beta. How much is given? 1.5 into sine 37. What is sine 37? Cos is 4 by 5, sine is opposite side 3 by 5. So 1.5 into 3 by 5. 5 ones are 5.5s are. So 5.3s are 0.9 meter per second square. So velocity in x direction is, so the acceleration in x direction is 1.2 meter per second square. Acceleration in y direction is, I'm erasing and just writing the value, 0.9 meter per second square. 0.9 meter per second square. So the first job is successfully done. I have divided into east and west, that is x direction and y direction successfully, right? Next, what to do? Take it to London. Where is the London? At which point? At time t equal to 4 seconds. What is asking? Velocity and displacement. Very good. Please see here. We'll use the space here also. Now, first, in x direction, we'll start with x direction. What is the data we have in x direction? Initial velocity in x direction ux is equal to 8 meter per second. Acceleration in x direction ax is nothing but 1.2 meter per second square, and initially it is at origin. After time t equal to 4 seconds, he is asking velocity and displacement. Sir, listen carefully. Acceleration in x direction is already given constant acceleration, and in total is 1.5. In x direction it is 1.2, and it is a constant. If it is a constant, without any doubt, happily I can use the formula. What is that? Vx is equal to ux plus ax into t. So final velocity in x direction Vx is equal to ux 8 plus ax 1.2 into 4. 1.2 into 4 is 4.8. So final velocity in x direction is 8 plus 4, 12.8 meter per second. Next, what I want? Final position and displacement. How to get the displacement? X equal to, see, acceleration is constant. I have the right to use this. X equal to uxt plus half ax into t square. x equal to ux 8 into time 4 plus half ax 1.2 into t square, that is 4 square. 8 4s are 32 plus 2 into 12, so 2 by 12 0.6. 4 square is 16, 16 6 are 96, 9.6, so it will become 41.6 meters. Hope I'm correct. Please check the calculations once. Next, so I got final velocity and final position in x direction. Now go for the y direction. For y direction, what is given in the y direction? Initial velocity in y direction, you have the 0. Acceleration, initially it is at origin, y equal to 0. Acceleration in y direction, 0.9 meter per second square. After time t equal to 4 seconds, again I want to find the same velocity and position. Now what is that? Acceleration is a constant. Now I have the license to use the three beautiful formulas. So as I want the final velocity, Vy is equal to v equal to u plus uy plus ay into t. Initial velocity is 0, acceleration is 0.9 into 4 seconds. So velocity in y direction, Vy equal to 4 9s are 36, so 3.6 meter per second. So I got final velocity in y direction. Next, what I want? Final position in y direction. So what's the formula? Y equal to uy into t, ut plus half ay into t square. Initially it is at, in y direction it is having 0 plus half, acceleration 0.9 into t square is 4 square. So 4 square is 16, 16 by 2, 8, so 8 9s are 72, so 7.2 meters. So what we got is the final position. It is at x equal to 41.6 meters, x equal to 41.6 meters. So finally let us say this is my, somewhere here is my 41.6 meters in x, somewhere here is my 7.2. Don't worry with the scale, sir. So finally it is at this point. What is this point? 41.6 comma 7.2. So what is the vector going to be? What is the vector going to be? What is the final position vector going to be? What is the final position vector going to be? This is my final position vector. S bar is equal to how much distance along x-axis? 41.6 I cap plus y direction 7.2 j cap. And this is the angle made by the position vector. So from the origin, finally it is at a point, s equal to 41.6 square plus 7.2 square, and making an angle theta equal to tan inverse of y by x, that is 7.2 by 41.6. Get the values. .6 whole square plus 7.2 square under root 42.2 meters. Similarly, 7.2 divided by 41.6, shift tan of answer, that is 9.8 degrees. So it's at a distance of 42.2 meters from the origin and making an angle at an angle of how much? 9.8 degrees. Now he asked the final position. I got the position. Next I want final velocity. Now go for the velocity. So what's the final velocity in x direction I got? How much is the final velocity I got in x direction? We have here 12.8 meter per second square. Velocity in x direction, Vx is equal to 12.8 meter per second, and velocity in y direction, Vy is equal to velocity in y direction, Vy is equal to 3.6 meter per second. So the resultant velocity, this is the resultant velocity, V bar is equal to how much? 12.8 I cap plus 3.6 j cap, and this is the angle alpha. Now how to get the total velocity v? Under root of 12.8 whole square plus 3.6 square. So how much is that going to be? 12.8 square plus 3.6 square under root of answer. So that is 13.29 meter per second, making an angle of beta. What is beta? Sorry, alpha. What is alpha? Tan inverse of Vy. What is Vy? 3.6 by 12.8. So it's around 15.7 degrees. So we got the final position and also the final velocity. What's the final position? This is the final position, is equal to 42.2 and an angle of 9.8 degrees. And this is the final velocity, 13.2, making an angle of 15.7 degrees. So whatever he asked, we got them. Okay, so divide the problem into x and y direction, solve separately in x direction, solve separately in x direction, and then separately in y direction, and combine them, right? So this is the beautiful concept given by Newton. Okay, so we have one more problem, a general problem. We'll solve it, then go for the projectile motion. Make it a particle moves along the path y equal to x square minus 4x plus 100. Starting with an initial velocity v0 is equal to 4i cap minus 16 j cap. If Vx is constant, that means velocity in x direction. So remember, see, this is v0, that is u. Like generally we use the what's this, u, but he has given it as v0. Velocity in x direction is constant. What's the meaning of velocity in x direction is constant? What is the meaning of velocity in x direction is constant? What's the meaning of velocity in x direction is constant? What's the meaning of velocity in x direction is constant? He is not telling anything about Vy, forget. But if velocity in x direction is constant, what will happen to acceleration in x direction? Acceleration in x direction is nothing but what? Rate of change of velocity in x direction by time. If Vx is constant, derivative of Vx will become what? 0. That means indirectly is saying acceleration in x direction is constant. Velocity in x direction is constant. That means acceleration will become 0. That means acceleration in x direction will become 0. Very good. Next. The value of Vy and Ay, at x equal to 16 meters will be at x equal to 16 meters. What they want? Value of velocity and acceleration. These two we need to find out. Very good. Now please all of you see here. He has given y equal to x square minus 4x plus 100. He gave the relation between x and y. And he has given some information about x and he is asking about y. Now, how to get Vy and Ay? See, the beautiful thing in this is, sir, every problem cannot be solved in the same strategy, right? The beautiful thing in this is, it's not a combined function of x and y. Y in terms of x is given. So what I can do is, can I write, what is that? Can I write velocity in y direction is nothing but equal to dy by dt? Yes or no? And he gave the equation. What is y? X square minus 4x plus 100. X square minus 4x plus 100. So from this, what is velocity in y direction going to be? Differentiate it, 2x into, sir, this is x. We are differentiating with respect to time. Be cautious. Don't just write 2x. It is into dx by dt. minus 4. X derivative is 1 into dx by dt. Constant will become 0. So what is dx by dt? What is dx by dt? Dx by dt is nothing but velocity in x direction. Velocity in x direction. So what is that I'm going to get from that? So velocity in y direction is nothing but equal to 2x minus 4 into 2x minus 4 into 2x minus 4 into velocity in x direction. Where is he asking, sir? At x equal to 16 meters. At x equal to 16 meters. Vy at 16 meters. X equal to 16 meters. How much is that going to be? 2 into 16 minus 4 into velocity. So velocity is everywhere constant in x direction. It's not changing. It is everywhere constant in x direction. We have been given with the velocity vector. What is that? 4i cap minus 16j cap. So from this, what's the initial velocity in x direction? What's the initial velocity in x direction? 4, because an I cap is nothing but x direction. 4. And as acceleration is 0 and it is a constant, so anywhere it is at x equal to 1 or 100 or 16 or 20, it is always same. It is always same. So what's the velocity in x direction at x equal to 16 meters? 4. So this is 4. Now how much is that going to be? 16 2s are 32. 32 minus 4. 28. 28 into 4. 28 into 4. 112. So what is the velocity in y direction at x equal to 16 meters is 112 meter per second. Next, what is he asking? Velocity and acceleration. How to get acceleration? First derivative has given me velocity. Further, if you differentiate, you will get what? Acceleration, right? So acceleration in y direction is nothing but equal to dvy by dt. So if I do the differentiation here, d by dt of 2x minus 4 into vx. So he has given initially vx is a constant. So as it is a constant, I will take it out. I will take it out into 2x minus 4. 2 into the differentiation of x is 1 into dx by dt. 4 will become 0, right? So acceleration in y direction is equal to 2 into dx by dt is nothing but what? Vx. So into vx square. Already we have found out. What's that? Velocity in x direction is always constant, and it is 16, and anywhere it is constant, and it is equal to 4. So acceleration in y direction is equal to 2 into 4 square. 4 square is 16, 16 2s are 32. So acceleration in y direction is nothing but equal to 16 2s are 32 meter per second square. So what is the answer going to be? 112 and 32. So that is my option B. All of you are okay? Make a copy quickly. So with this, we are done with the basic 2D problems. Now we will go and apply this for the projectile motion. Hope you have gained some knowledge from my lecture. If you feel so, please subscribe to the channel. Please leave your valuable feedback and doubts in the comment section. For my complete video lecture series, enroll in OCTEMY. Thank you. Let's catch you soon in OCTEMY. Have a good day.